Okay, good morning, everyone. My name is Suraj Desai. I'm a professor of climate change adaptation at the University of Leeds, and I'll be moderating this panel together with Marta Terrado. Marta, do you want to say a few words?
Hi, I'm Marta Terrado, and I'm a science communication expert at the Barcelona Supercomputing Center, and I'm glad to also be moderating this forum with Suraj.
So we are a guest session for the Climate Europe 2 Web Festival, and over the next 2.5 hours, we'll be actually running the first user forum of this new project called Aspect, Adaptation-Oriented Seamless Predictions of European Climate. Andrea, could you put our first slide of the agenda, please? So I can just tell you a little bit about what we've got planned over the next 2.5 hours. So we are going to have a brief introduction to the project from Jason Lowe at the Met Office. We're going to have a few interactive sessions where we'll be using Menti. And you'll hear from one of our super users, as well as from one of our researchers who's been doing some work around the assessment of user needs. And you'll hear a little bit about people who've been translating climate information into usable products as well. And we'll also have a bit of an announcement around our recruitment of future super users. But before we get started, Marta and I are going to just chat a little bit about Aspect, actually, to give you a little bit of a feel about why, what the project's about, and why we're here as well in particular. And I should mention that this is actually the first part of a two-part user forum. So really today is an introduction to the project to give you a little bit of a flavor of what the project does. But we're going to follow this up in April, on the 21st of April, in the morning of the 21st of April. And Andrea, if you can put the Zoom link in the chat, you can then register for the second part. And I'll mention this again at the end of the event today. But to get us going, Marta, could you tell us a little bit about Aspect, please?
Sure. So Aspect is a project that is coordinated by the Barcelona Supercomputing Center. And the aim of the project is to improve stakeholder decisions that are affected by climate. For that, the project will produce enhanced climate prediction that will cover the next 30 years. And it will also generate novel predictions, so what we call seamless climate predictions, which will integrate information across different timescales, which have traditionally been provided separately by different prediction systems, but the idea is to have them now in a seamless way. This will be done placing the users at the center and looking at how climate change adaptation decisions change over a range of sectors, temporal scales, spatial scales, and also across different decision-making levels. We will hear much more about that in a minute during the presentation of Jason Lowe right after this short introduction. But today, as Suraj explained, we are in the first part of this user forum, and this is also the first user forum, which means that there are more to come in the future. So Suraj, can you give us more information about what the user fora are and also how they are going to be used in the context of Aspect?
Yes, so this is the first. So the project started on the 1st of January, and then our plans are to have annual user forum as a means to bring together the user community that potentially can use climate information in their decision-making, or some of the colleagues who are translating complex climate information into useful tools that decision makers can use, sometimes called purveyors, for example. So to bring that community together with some of the Aspect scientists that are pushing some of the science forward, particularly at the seasonal to interannual decadal prediction timescale. So this really is the first of an annual event. And I should also mention that the other aspect that I guess we've got in the project is that we have a cohort of super users with whom we're working very closely to develop, tools and in a sense, climate services for them at this particular timescale. And you'll hear from Javier Bordes from Codernu in a little while. We have a couple more, and then Dan Burney will tell you a little bit about how potentially you could also become a super user as part of the project in the future. But certainly, not everyone can become a super user within the project. So really, we want to use the user forum to tell you a little bit about what's available now in terms of the scientific climate information that decision makers can use to inform their decision making, but also what will become available throughout this project in the next 4 years that could be used in decision making. So that's the plan for the next few years. And I think I've seen Andrea has put the link to part 2 of our user forum, and really, I guess the idea with part 2 is that we're going to be able to go into more technical detail. So today you'll hear broadly about what the project is doing, but if you want to have, for example, more interaction with some of our climate scientists about what could become available in the next couple of years, particular climate variables and so on, then that's the type of discussion we'll have on the 21st of April. So you'll hear more about the science, but there'll also be more opportunity to engage directly with some of the scientists, and we're going to have a little bit more time as well. So that's as much as Marta and I wanted to introduce the project. I'm now going to hand over to Professor Jason Lowe. So Jason is a principal fellow and head of climate services for government at the UK Met Office. He's also a colleague at the University of Leeds, where he has a chair in interdisciplinary climate research, and he's been doing climate research for over 20 years with many publications to his name, involved in developing of national climate scenarios, as well as the UK climate change risk assessment, and has also contributed to the various working groups of the Intergovernmental Panel on Climate Change. And he was, he's been deeply involved in aspects. So Jason, I'm going to hand over to you to tell us a bit more about what the Aspect project is going to do. Over to you.
Thanks, Suraj and Marta. It's always really exciting, isn't it, at this stage in a project? We're just starting up, and we're starting to meet new people, new users, new colleagues to collaborate with. I think it's a wonderful stage of a project. What I'm going to try and do is build on the introduction that Suraj and Marta have given, with a little bit more detail and some graphics to help us think through this. Next slide, please. So I want to start by thinking about where we are. Society clearly has been through a period where the climate has already changed, and the plot on the left-hand side, it's showing the global average temperature from pre-industrial levels. Last year was the 6th warmest on record, but you can see, as well as that trend upwards in the figure, you can also see the year-to-year variations and natural variability. And as we move through the present into the future, we have to capture both that trend due to large-scale climate change, but we also need to think about how it interacts with the changing variability. An Aspect will do that. On the right-hand side, I wanted to illustrate that when we think of climate change, we need to also think about extremes. And we've already seen detectable changes in, for instance, intense rainfall events or very high temperature events. And we're starting at many locations to see an emergence of the signal for drought. We're also seeing big changes in aspects such as sea level rise and changes in Arctic sea ice cover. And the latter can be very important because it has an important impact on European climate as well as local consequences. Next slide, please. So a question that I'm guessing a number of you ask yourselves: how can I make better climate sensitive decisions? As a user, How can I bring the information that scientists like myself, Suraj Marta, Dan Burney, who's speaking later, how can we take that information, access it and use it in a way that makes a difference to our organizations? And this diagram, it's trying to capture some of the types of decisions that people make across timescales. So you can see going from left to right, we're going to longer and longer timescales. And aspect will sit in this space going from a season up to around 30 years ahead. And you can see within that space, there are actually a very large number of decisions as we move from the tactical into the strategic. So those include thinking about resource planning. Reinsurance decisions take place in that space. Thinking about investment strategies, thinking about risks to assets and property portfolios sit in that category. Regulator standards, updating them and complying with them sit in that category. And overall, it's a space where we need to think about adaptation to present and future climate. Aspect will help with that. And ultimately, how can we help to make better decisions? Well, by using better climate information, by using more relevant climate information, by making sure we have easier access to the climate information, and also by bringing together the weather and climate information with much more user relevant information on exposure and vulnerability. We'll hear more about that from the case studies. Next slide, please. One way I think about this is that what we're trying to do in Aspect is help you navigate from where we are now, around 1.1, 1.2 degree world above pre-industrial, into a 1.5 or a 2 degree world. And the plot I put here, it's showing the median model response across all of the scenarios covered in IPCC Working Group 3 for 2020 and 2050. And it illustrates this idea that Aspect is sitting in this space as we move towards a 1.5 or 2 degree world. Next slide, please. So what is Aspect? So Aspect is an acronym built from what we're actually trying to do. So the A is coming from adaptation orientated. So we'll provide methods and data, and we will work with you to help you use that to inform and plan adaptation. The S and the P, that comes from seamless predictions. So we're trying to produce seamless advice across timescales from the seasonal up to 30 years ahead. We still need to understand whether that means the actual predictions need to be seamless. And our focus is on the European climate. That's the ECT part of it. But the methods we develop will be relevant to other parts of the world too. We started the project running in January of this year and will run to December 2026. So we have 4 years. We had the first meeting, the kickoff meeting in Exeter in February, and that was a great opportunity for the colleagues within the program really to get together and start to understand the detail of the scientific questions we'll try to answer, and also how we can work best with the user community. We'll also be, as part of the project, developing a prototype delivery system, but it's worth emphasizing that we are a research project rather than an operational project, but we want to leave behind a legacy that can feed into operations at the next stage. Next slide, please. When we think about users, I sometimes think it's very useful to have a philosophy of user interaction. And the one I'm hoping we're able to use within Aspect is that the users are central to the project, and actually that the scientists will be driven by the users. They'll still bring in the really important scientific drivers as well, the knowledge of where gaps are and the opportunities to fill that. But the role of users will be much greater than in some earlier projects. We also, when thinking of the philosophy, we acknowledge that the users, you know more about your applications than we do, and that the co-development and the co-production approaches, they need to put those of us who fall into the purveyor category and those who might fall into the user category on an equal footing for the discussions. And we also note that those definitions are fluid. So sometimes people who are users might also consider themselves purveyors and vice versa. And the left-hand side tries to indicate that the hierarchy of users within the project. So at the center are a relatively small number of super users, and we'll hear from them or their representatives later in the session. But we'll work very closely with those users. We'll actually develop applications that draw on the new science that we're producing. We want to go wider than that, and today's event is part of that, of building a wider engaged community. And we're hoping that you can provide guiding input and that we can provide benefit to you on the early results. In this layer, we also have some dedicated effort to work with Met services, because they're often a route to helping to broadcast and spread the value of climate information. Now, just looking at the number of participants today, it's clear not all climate service users and purveyors can attend a forum like this. And we do want to go even further afield. We'll try to reach those users through our communication approaches, but also through the data delivery systems that we're building. And that idea of amplifying to a greater number is really important. I hope many people here could act as champions for some of those discussions in the wider community. Next slide, please. In terms of the case studies, so we wanted to look across a range of spatial scales, from the very local up to the national and regional scale. And we wanted to make sure we were looking across time scales from a month or so out to the 30-year time horizon. And in the beginning, we have 3 case study areas. So the first one focuses on agriculture, and in particular the grape and wine sector. And here, you'll hear more later, but there are a range of decisions that span this set of time horizons, and making sure we have good quality information, and that there's a consistency in the understanding of that information, so that decisions can be made in the best way, is really important. We'll tease that out. A second case study focuses on the finance sector, and in particular pensions. Now, this is an area where actually there's a real appetite to engage with climate decision making, and that has started, but some parts of the finance sector are really still at the awareness raising stage. And we're very keen to make sure that we can bring colleagues in the finance sector through different stages to have access to the best information on the timescale up to 30 years. And this includes thinking about early warning around near-term investments, but also longer-term investment decisions and horizon scanning, thinking about what the implications might be for demand and how that could affect an investment portfolio. The third example focuses on governance, and this is linked to the mission on climate adaptation. And here we're trying to produce improved risk assessments and adaptation plans. There are 2 gaps where we can add additional users. We'll hear more about that later, but I'd encourage you to think, could you be in one of those slots? Would you want to be involved in one of those slots? What benefit might it bring to you? Next slide, please. And I mentioned this idea of a delivery system. So we want to bring together the data that we produce and the methods expressed as workflows, and make sure that these can be put out to a wider audience. And we're very lucky to have ECMWF within the project, so they can bring the type of learning they've built up within C3S around the climate data store. And this diagram, it's showing one such workflow going from the data all the way through to the end users. And we're hoping we can encourage a similar ecosystem to form around the types of data we produce in Aspect. We'll also consider other parts of upscaling that are more organization and methodological and go beyond the data. And these will build, for instance, on toolkits in other projects, such as the SPF UK Climate Resilience Programme. Next slide, please. Okay, so many of the people in the audience will come from a scientific background, and it's important that we have within Aspect really good quality, cutting edge scientific research. And I want to show the three areas that we'll focus on with that research. And the first one is that Aspect will improve seasonal to decadal forecasts. And that includes making better initialization methods, including for the slower varying components of the Earth system, but also getting better at representing uncertainty. And whether that comes from the external forcing or the initial condition or missing processes, uncertainty is absolutely vital for the decisions that people make on the back of this data. And we'll look at the benefits of increased vertical and horizontal resolution. The plot on the right-hand side is from earlier work, and it's showing different ways of combining the results from different decadal forecast systems. That will be important here. Next slide, please. The second component of Aspect will develop and compare methods to produce the seamless predictions to 30 years. So you'll know that climate projections are not initialized with recent observations. And at the moment, if people want to look across timescales from a season out to 30 years, they're often taking data from very different systems. You can see that in the middle plot, with the blue being the predictions and the orange being the projections. The trouble with that is that there are mismatches and inconsistencies. And what we really need is the right-hand plot, where we've built that consistency through the timescales. And in Aspect, we have two ways of doing that. One way we'll investigate is taking the initialized forecasts and running them further into the future. That has a lot of technical challenges, but it's a question we really hope to advance. The second is actually taking the data from different systems and merging them in some way, either through, for instance, a constraining approach or intelligent stitching together of the different ensemble members from different timescales. Next slide, please. The final area I want to highlight is that because adaptation is place-based, it's local, we need to be able to downscale the results. And we need to be able to downscale the results for quantities that are extreme or rare. Often these are associated with the greatest damage. On the left-hand side, I'm illustrating that with the latest generation of very high resolution convective permitting models, we can capture many features of the observations. This is showing the simulation over the Alpine region, which is a particularly difficult region to capture. And the plot next to it is showing rainfall intensity from era 5, the black line, through a traditional regional model. These are usually around 12 kilometers. But if we want to get near to the observations, in this case, the green line showing radar observations, only the very high resolution models are able to do that. So we'll be looking at downscaling approaches to derive climatologies of extreme events. We'll also be recognizing that people need time series. So we'll be using statistical methods to downscale the full time series period. And we'll make use of a variety of techniques, including drawing on the convective permitting models that have been developed over recent years, but we'll look at analog approaches and also machine learning techniques as part of the study. So to finish, the last slide, please, focuses on the legacy of the project. There'll be a scientific legacy, new methodologies developed with the users. So improved models and experimental design, appropriate downscaling techniques, and improved time merging. There'll be new data sets focusing on time merged or seamless over time, and also the extended initialized experiments. And we hope there'll also be a capable and enabled user community that will contribute through these user forums, case studies, the data delivery activities, and also the advice to Met services. And I think there we'll stop. Thank you very much.
Great. Thank you very much, Jason, for giving us that overview of the Aspect project. Please, this is your chance to ask Jason some questions. So please, if you've got any questions, put them in the Q&A. You'll find that function at the bottom of your screen. So while we wait for those questions to come in, Jason, maybe I'm gonna kickstart with one. I wonder if you could, decadal forecasting is still sort of relatively new. So I wonder if you could, contrast that with, people are more used to using weather forecasts. Some people may have used seasonal forecasts or even long-term forecasts for their kind of near-term and long-term planning. But the whole decadal timescale and technology is relatively new. So how does it compare with some of the other timescales, and what do you see the benefits of users taking that up?
Yeah. So firstly, the models are actually very similar and often the same as those we use either on the seasonal timescale or for climate projections. So we're using models that we have experience with on other timescales. We've been able to evaluate the quality of. I think that the difference is when we realized how much skill we could tease out on this time scale of a few months to a few years, because you'll know this from discussions in the community, that's the time scale that organizations are making some of the key strategic and investment decisions. And I think that the key difference is at the moment the community is, I think, starting to realize, hang on, there may be something new in terms of information we can feed into decisions on this time scale. But what we haven't done yet is worked out how we can feed the sort of amounts of skill we're getting into those decisions. So it's a little bit different, mainly because of the decision making, I think, than the seasonal or the projections. I think the other thing that's quite exciting is that, I mean, scientifically, it's moving from trying to latch onto natural variability and follow it forward. But it's combining that with the emergence of the external forcing signal. And it's bringing both of those together. So from the scientific side, it's also really, really exciting. But what I'm hoping in this work will do is that we know we can already produce decadal forecasts operationally. What we need to do is make them both decision relevant and used in decisions beyond the pilot studies, I think. And at the moment, the decadal forecasts are largely in that pilot study space for many, but not all applications. Whereas seasonal, we're now seeing used to make operational decisions, for instance, in the energy sector, thinking about wind droughts, transport sector, planning ahead for the coming winter. We haven't quite got to that point yet, but I don't think we're that far off with decadal forecasting.
Great, thanks, Jason. There's a question that's come in from Paul Young, and I know it's a topic you're very interested in on uncertainty, Jason. So let me read that out. Can you say something about how you'll be thinking about weather uncertainty versus climate signal, particularly at those highly resolved scales? Large initial condition ensembles teach us about the range of possible worlds there are when we go out a few decades, or should we be thinking more about collapsing that uncertainty and going for storyline approaches? So that's an very interesting debate that's still ongoing in the community. What's your view?
Yeah, so I mean, let's first think about where the uncertainty is coming from in the climate information. In the near term, the emission scenarios are really quite close together. So even at the end of the decadal forecasts and towards the 30-year period, the emission scenario uncertainty is probably not dominating. Where the uncertainty is being dominated is from natural variability, just as it is with weather forecasts, and we're trying to follow that forward, and also structural differences in the model. And I'm pleased that within Aspect, we have access to several different modeling systems on the decadal timescale. So we can look at both that structural uncertainty and natural variability. And we can also pool the ensemble members to get further into the tail of natural variability. The uncertainty aspect, I think, is absolutely key to then bring through into the decision making. So uncertainty is not going to go away. over time. We can improve the models, but really what we're trying to do is come up with a better aspect of uncertainty, so that in the decision or the decisions that are made, we can have confidence in that level of uncertainty. Now, what does that actually mean for this idea of thinking in probabilistic terms or storyline terms? I think both have their place. I think storylines are very good for, firstly, for communicating what is happening and raising awareness. I think they're very good for thinking about the causes of a particular type of damaging event. It lets us unravel that physical chain, and it lets us check if the model is capturing the real world. And I personally see it sitting alongside the more frequency or probability based, and figuring out how that plays out in decisions. That's one of the things we want to do. We saw really useful work in a C3S project that looked at this for sectors like energy and initially in one part of finance. We get a chance to dive more deeply. And if Paul has any real suggestions about how we use both methods together, I think we'd really like to hear more as well, because we can definitely keep learning about this.
Great, thank you, Jason, and thanks, Paul, for the question. Okay, I'm going to try to sneak one more in here now from Harry Lavis. The maximum improvement potential for Seamless can be evaluated assuming, for example, perfect seasonal forecast and its impact on decadal and further on projections. Do you have any comments? I guess it's about, the evaluation of the forecasts from seasonal to decadal predictions, Jason.
I was reading it another way. I was reading it as focused on the maximum level of skill that you might get as you go through the system. And do we think about that? Yes, of course we do. I have in mind instantly a plot from Adam Skaith that looks at skill plotted against ensemble size, for instance. And so we can think about what the maximum would be across that time scale, and we can play those thought events with users as well, to say, look, if we had that maximum skill, what would it mean for your decision, as well as what does it mean with the actual skill we've got in between. I also, if you take it the other way around, the question, can we actually push the skill using the understanding we have of the sources of predictability, including what we learn from the seasonal forecast? I think yes, I think that can help inform the improvements in the models and also the initialization systems.
Great. Thank you very much again, Jason, for that presentation and answering, and thank you for the audience for asking the questions. We must move on now, and we wanted to move to an interactive session. I'm going to ask Andrea to share her screen next, because we wanted to see who's in the room, actually. I mean, one of the kind of features of Zoom is that we can't all see each other and who's here. So if you could please go to Menti, got the website there, and enter that code or use the QR code. You'll see our first question. I guess we wanted to figure out whether, are you a producer of climate information? Are you already a user of climate information? Are you a potential user of climate information? Maybe you haven't used it before. Are you a purveyor or translator of climate information? So that's the first question we wanted to put to you, our audience. And if you could, answer that question, and then Andrea's already showing us some of the output. There'll be a lag. We know how we have more than 100 attendees, so I hope that head count on the bottom right will keep going up. Okay, I think we're reaching about 50%, so that's still going. Okay, great. So, we have quite a lot of colleagues who are translating climate information into to other, products, tools that can be used by decision makers. That's our biggest group here, and it's great to have you. Thanks for coming. Clearly, I think Aspect has got things that will be of interest to you, and you're going to be really critical in making this useful and usable to the to decision makers that need to make adaptation decisions across Europe. We have also quite a lot of producers here, so people presumably involved in producing seasonal forecasts, decadal, that Jason mentioned, but also other climate information. And we have some users and some potential users. That's a smaller group, but if you add them up, that's a bit over 20%. Okay, it's just jumped up 1%. So it's good to see you here as well. So thank you for answering that question. It's great to see who's here. So if we could move to the next question, Andrea, we wanted to find out, how often do you use climate information, in yourself or your organization? And clearly, sometimes this might not be applicable. If you're producing climate information, you might not be using it as well. We'll just wait a couple of minutes to see. It's a lot of use of climate information at the moment. Okay, I think that's probably stabilized now. So there's quite a lot of use of climate information amongst the group here today. They're always using it, and then so that's quite interesting. It's a group that's already using climate information quite a lot. So I think, let's just move to the final bit of the question, which is which I think will be interesting. We wanted to find out a little bit about, why are you using climate information, or why might you use climate information in your organization? And you have to do it in a small amount of words. There's a limit to characters, but it could be things like maximizing performance in your organization, or it might be protecting lives, or there might be many reasons. You can put in 3 different reasons about why you might use climate information. And we wanted to, hopefully we'll get a bit of a word cloud coming up. Okay, this Mentimeter is definitely challenging my eyesight. But I'm going to try to read out and see some of the things that are coming up. Clearly, climate services is coming up as a word that has been repeated by multiple colleagues here. So that's important. Informing decisions. I'm also seeing early warning. definitely saw climate change adaptation earlier as well, supporting adaptation. Yeah, I don't know if your eyesight is better, Marta, but if you want to pick out anything else that you can see, please do before I
Yeah, we have also managed the production, policy change. Yeah, but basically those. Research now it's appearing. But we have a varied range of, applications of climate information.
Yeah, and I think what's quite interesting is to see the sectoral elements coming up as well. So I can see sort of power plants, insurance. I'm sure I saw agriculture, biodiversity loss. So this is trying to inform a variety of sectoral decision making, international development as well. But yes, it's interesting to see assess physical risk. I guess could be connected with TCFD, for example. But yeah, the kind of, I guess, key words that are coming out are climate services, research, early warning systems, informing decisions. Yeah, we'll pass this on to one of our colleagues, Carmen, who will be doing a bit of a summary at the end of the festival, and hopefully she can digest a little bit more of this, because now I think in the interest of time, we should finish this particular interactive session, and I'll hand over to you, Marta, to introduce our super user.
Okay, yeah, before introducing the super user, thanks to the audience for participating in the poll. It has been very useful to see the profiles that are among the audience today, and also the extent to which you are using or might consider using climate information, and also to see this word cloud. Now let me introduce our next speaker, who is one of the super users that we have in Aspect, actually. He is Xavier Bordes. You can see him now on the screen. And he is from Raventós Codorniu, which is the oldest wine company in Spain, with more than 470 years of history in the production of quality wines and cava. The company is also one of the largest vineyard owners in Europe, and they have been previously involved in other projects where they have been exploring how to use climate predictions for decision making, actually, mostly for operational decisions at shorter time scales, at seasonal time scales. But Xavier, now can you explain us more about how is your company using climate predictions, and also the benefits that you get from doing that, or that you expect to get? So yeah, the floor is yours.
Thank you, Marta. Hi, everyone. And also thank you for letting us being part of the project, this fascinating project, and also for inviting us to talk in this forum and to share our experience in the matter. First of all, as Marta said, my main task every day. The task of our team is to produce grapes for wine and sparkling wine production. So we are, as we working in agriculture, we are exposed to weather and climate change. So we are highly vulnerable to the plants. Not we, but the plants are highly affected by these changes in climate that are happening these days. And we are used to work a lot with weather forecast with shorter time scales, but it's true that we are not that used to work with climate predictions. And this project is for us an opportunity to explore the kind of decisions that we can take in order to take advantage of the knowledge that these climate predictions might suppose to us. How, for example, which strategic decisions do we face? For example, if we to better understand, to better predict how to prune the vines, and also maybe if it's we know probabilities of rainfall, to try to choose better cover crops, and also for investments. We have to if spring frost is a phenomena that it's going to be quite likely to happen in the future years. Is it good? Is it advisable to install these spring frost protection systems? The same for heat waves, as Jason said, that the climate change implies a higher mid temperature, but also the extremes are also farther away. So the extremes is what also the plants get affected the most, and this is the kind of information that we work with the project to try to incorporate in our decision-making process. As I said, we are highly used, of course, to use the weather forecast for 1 week, maybe 2 weeks, tomorrow, but it's a challenge for us to try to incorporate all this information in our decision-making process and to try to improve the management of the vines. We had, as Marta said, we get in touch with these climate predictions in another project called DISCA. And so when we had an opportunity to further explore these climate predictions, we didn't hesitate and try to learn the much of it, and as I said, to take advantage of all the information that we can take from the project. It's a challenge for us, and it's a challenge that we will share in the work package 4 of this project to try to get some data or some variables that to introduce in our daily basis or when we try to plan the works and all the things that we have to, the labors that we have to take care of on the vineyards.
Thank you, Xavi. So let's see if in the audience we have any questions. Remember that you have the Q&A button to submit them, but in the meantime, I would like to ask you 2 different things. First, perhaps if you could comment on pick one of the main climate-related concerns that you have in the company, thinking on all this range of scales that we want to cover in aspects, so going from the seasonal up to 30 years. And then also regarding this decision, which are the expectations that the company has from Aspect, let's say? So what do you expect Aspect could add to your decisions?
The first question was, for example, we are in the middle of the spring, and the vines are just bursting, and the spring frost is one of the main damages or the main phenomena that can affect our vineyards, and it compromises the whole production of the year. So to have this information of how it is likely to happen, these temperatures below 0 in the months in the April month, for example, how it is likely this to happen will gives us a clue or whether we have to invest in a spring frost protection system or not. The same, for example, it is funny because the same spring frost protection system can protect from heat waves. So on the other hand, we have that we also would like to know the probability of these heat waves to happen. For example, how likely is or how many probability of having days up more than 40 degrees during summer. So it's that we have also make decisions according to this information, and also in a thinking in this is valid for seasonal and also for decadal predictions, because the investments of this equipment can go through many years, for sure more than 10-20 years. And also in another aspect, we also, this information is useful to in the context of that we are experiencing now of less rainfall. It is also very useful to know whether we will have to invest in building bigger reservoirs of water. We have to work towards higher efficiency irrigation systems, and the challenges that the climate change is presenting sure will push science and to improve how we use water nowadays. Not just viticulture, the whole agriculture world have to learn to use water in a very efficient way, and these climate predictions sure will, if we can take advantage and can go one step forward. It's not as I heard somewhere, it's not to fight against the climate change, it's to adapt to climate change. And this is what we expect from Aspect, is to provide us tools and to work together to get tools in order to make our company more resilient and have and adapt to the days that are going to come.
Okay, thanks. Also, when you mention decisions at longer timescales for the next years, and decades, you refer to these strategic investment decisions sometimes, or strategic measures that you plan to implement. Does it make any difference when thinking about these strategic decisions to think about 10 years time, 20 years time, 30 years time? Or is it any decision applicable, let's say, to 10 years time, but not to 30? Does it make any difference looking at these longer term time scales separately?
The truth is that we are living in a world that companies, what they look for is immediate revenue. So it's hard for many companies to make an investment thinking in 20 years now, because what the companies look for is to get the higher to return the higher investment as quick as possible. But so that's why it's we are technicians. We are not the people that handles the money, but that's why we are still learning how to take advantage of these seasonals information, and it is harder. It is hard for us to implement this decadal information, although it's the value of the information. It is there, and for anyone that is willing to take advantage of it, it's I think it's worthwhile to take it into account for sure.
Yeah, and also thank you. And a last question from me, and hopefully we will get some from the audience as well, is that so when we think of vineyards, we think about a type of of crop, or I don't know if we can say crop, but a type of product that when you decide to plant a vineyard, it's for a long term. So it can, you know, the lifetime can be up to 30 years or perhaps more, but you know better. And then can you comment on how different is the vineyard than compared to other crops that are more, you know, that you can change more often? And if there are some decisions that apply more to the vineyard than to these other types of crops. So we can see how different is the agriculture sector depending on the crop you think about.
Yeah, for sure. When you plant a vineyard, you expect to getting fruits from that plant, as you said, 20, 30 years. So it's a long-term investment, and that's for sure. And all the decisions that we make at the time that of implanting the plants are very different. For example, for an annual crop, just like wheat or alfalfa or barley or corn, that you can adapt when this, for example, taking into account cereals, depending on the conditions of the year. For example, this year is we are already in shortage of water, so all the farmers in the area have been advised not to plant corn on the whole surface because it won't be enough water to irrigate them. We have not we have the vineyards in the field, so we have to adapt to what we have. We cannot decide, okay, this year we will not irrigate the vineyards because then we get nothing from the plant. Also, what is the climate, these higher temperatures, what they are bringing, it's not all negative effects. The sugar accumulation is higher, for example, and also maybe there will be field for maybe varieties that were not used now because they had longer cycles. Maybe there will be an alternative, considering that the temperatures will be rising, the mid temperature, that we will have to also, when we considering that a vineyard is in the field for 20, 30 years, to grow plants or grow varieties that are better adapted to the future conditions that we will have in these 10, 20, 30 years than compared that what the varieties that we have now, that maybe some of them will its performance will be worse in the future conditions than it is right now.
Yeah, now that, yeah, Suraj, please go ahead.
Yeah, if I may, I wanted to ask a quick question, Javier. As you know, these climate models sort of output lots of different climate variables. So temperature, soil moisture, rainfall, there's a lot of things that come out of the climate models. I mean, could you just say a little bit about like what are the most important thing, you know, based on your interactions up to now with climate scientists, like what are the most important climate variables for your decision making? Is it, for example, figuring out, you know, spring frost, or is it, you know, soil moisture, you know, deficit or surplus, or is it rainfall or temperature? It'd be good to just get a sense of, you know, the most important climate variables for your decision making. Thanks.
You're welcome. As I said, all changes, all variables affect directly to the plant performance during the season. Temperature and rainfall are for sure the most maybe immediate variables that we would like to know better of in the future or in the coming years. The probability of the rainfall is this area that these 2 years that the last 2 years are going to be more likely to happen with less rainfall, or there will be, and again, a mix of high rainfall, low rainfall that we had in the past, and also the extremes, hot temperatures in summer, low temperatures in spring. This affects us a lot to the plant performance, affects a lot to grape production and to quality, not just quantity, but quality of the grapes, because the extremely heat waves during summer can worse for sure the production with undesirable the response from the grapes, and I think this rainfall and temperature are maybe the ones that focus our interest most. And rainfall, it's important not just, for example, how to predict to know what will be the water needs for the plant, because we are in our area, we irrigate, and the water that doesn't come from the sky, we have to apply it from our reservoirs. And also, not just this, but for example, in spring, it's also important to know or to have information about what probably will be the rainfall, because temperature and rainfall affects directly to disease cycle of the vineyard. And so we will also be able to know if it will be a year with lots of pressure of diseases, if it's going to be very, very it's going to rain in spring, or on the other hand, if the spring is going to be drier than normal, maybe we won't have that much disease danger in the horizon.
Yeah, thanks, Xavier. Actually, we have started to receive questions now on the chat, and we are nearing the end of our session. But since there are two that are quite connected, I will ask you these questions, if you can be brief answering before we go to the break, because I think they are interesting. They relate to what you mentioned about the use of more resistant varieties for the grape. And the questions, one of the questions which Ott sent is about if you have some constraint when you select these varieties regarding to the labels associated to your wine, because this control appellation, so okay. And also there is a question from Sayed that it's about if yeah, perhaps it's not that related, but I was thinking that also because he's mentioning about the taste of the wine, when you change the varieties, or even when you adapt it to climate change, also it can be that the quality of the wine changes, and then the taste, and then in the end it reverts to the origin or to the definition of your wine as well. So how does climate change affect to these two different aspects?
These are very good points, both of them. So first I will focus on the first. It is true that there is a restriction on varieties. So the direction to adapting in this way, it must work in two ways. First of all, although there are some varieties that are accepted for each appellation of origin are defined, but amongst these varieties, most appellation of origins have many varieties which are accepted. Amongst these, there are for sure varieties that have longer or shorter cycles, so you can move between the ones that you have available right now. And it is true that at least the world of wine, it's quite traditional, and to introduce changes and to introduce changes in varieties, it's also difficult sometimes. But this will test the resilience of the sector. You will have to adapt, and this maybe will force to open minds in different levels of the wine sector, and will maybe for sure force that we improve the material, the plants that we are putting in our fields, because if we have to stay like this and die, maybe to adapt, to change and survive. This is like it's being to the extreme, but the bottom line is this one. And regarding to the other question of the taste of wine, it's in a way it's the climate change is changing the taste of wines. With the same variety, different conditions, it's already changing the taste of wine. Maybe the thing is that the change is gradual, and we are maybe not noticing it. But the truth is that lately, wines, 15 years before, these reserve wines with these old wines were the wines that people like the most, and today the market is moving towards more fresh wines, more fruity wines, and maybe this is also indirectly a consequence of the potential that these higher temperatures can bring to accelerate the ripening of the grapes and bring these wines. And also these also, if we, and this in the other hand, if we change varieties, changing a variety does not forcefully mean a radical change of wine. So this also will be a challenge for enologists, the more industrial part of the wine, to get these the better wines of the situation. And there are plenty of varieties out there that have very, very good quality, but maybe we know that this wall of wine moves with waves, and marketing and many other factors affect that are beyond the quality of the wine. It's more perception of the quality of the wine, but this is just another different question.
Okay, thank you, Xavier, and also for explaining all this complexity, because of course, the business is much more complex than we can imagine, and there are many things that need to be considered. Now, unfortunately, we cannot continue with the session, but perhaps you can answer to some of the questions that we have in the question and answers. So in the chat, and then provide some insights for people that have some doubts.
Okay.
And to our audience, we have now completed the first part of this session, so we will have 10 minutes break. It's a little bit shorter. But you can get some fresh air or have a coffee or have a nap or whatever. And we reconvene at 11:20. And when we will have some interesting announcements to share with you. So see you in 10 minutes.
Hello, everybody. It's a great pleasure to record this video for all the attendees at the Web Festival of Climate Europe 2. It's a great event, a very good way to gather all the experts of climate services in Europe and beyond. Having also followed as an external participant the activities in Climate Europe 1, I think it's a very good way to keep track of what's happening in the arena of climate services. We've made such a big progress in about 10 years since the very first projects on climate services, at least those that are now referred as climate services. there were activities on climate services before, but technically we started around 10 years ago, I would say. So it's something that has helped progress this sector enormously, and I'm very happy to be part of it, having also coordinated very exciting project with Secli Firm and being part now of another exciting project with Focus Africa. That's a key component, to have a close stakeholder engagement as part of the co-production of climate services. It would be useless to produce climate services on sitting on a desk and just looking at the results on your screen, as most scientists do. Really reach out to users, interact with them, find what is useful, what can be improved, and so on. It's a continuous process. It takes a long time, but we're making very good strides, and the achievements that have been done so far are visible, with a lot of activities, also spin-off companies and so on, that have started on the back of all this funding. That's tangible, very clear and good result of all the funding that the EU has put on the table. And so we've achieved a lot. Now we are in a stage, particularly with the projects like Climate Europe 2, which are going to help to amalgamate even more all these activities. I'm particularly interested to follow, and also concerned about, the implications for ethical considerations of use of climate data. And I hope that Climate Europe will help provide some guidelines.
I'm Isadora Jimenez. I work at Lobelia Earth, and I have been working in climate services since 2015. Over the years, my understanding of what climate services are has been changing and evolving. And over the years, what I have realized is there are plenty of communities beyond climate that are working in services, and something that we could call that they are climate services or services for climate change adaptation. And what I see for the climate services community, or the future of the next years, is that I would like to see more of a collaboration of these different communities working together. And sometimes when we talk about climate services, somehow if we say something about weather services, it seems that it's something completely different, but there's a strong overlap. And this makes that, because we call them different, different communities are having the same problems, are facing the same challenges, but they don't always have the spaces and the communities to be changing and working together and sharing these experiences. And what I see for the future of climate services is really to focus more and more into people and what people need. And people can be from citizens to private companies to big institutions and organizations. Which are the problems they are facing, how climate and any other type of information is useful for them to make informed decisions, and how the communities and the experts in climate, in weather, in emergency management can really be pushing this information and helping them to make informed decisions. So I think the future of climate services is getting a bit less attached from the word climate and really thinking on services. Which are the services that are needed, which is the information that is needed, and who are the different communities that can serve this information to the users.
Good morning, my name is Tang Lei. I'm based in Paris. I've been working with EIT Climate Kick for more than 10 years now. I've been director for France and the Mediterranean, and now I'm director for performance and impact. My engagements with climate services has come essentially through one of the pioneering projects supported by the European Commission, which was called Marco. So that was one of the first attempts to understand this very elusive but very promising market of climate. In short, climate services are not very well understood still. Even the phrase climate services raises some eyebrows, and yet they are indispensable to support and enable adaptation and resilience at scale. They are also very important, of course, to enable communities, not just climate experts, to understand their greenhouse gas emissions in sufficient details and timeliness to take action on them. The multiplicity of actors, of perspectives, of metrics, and also the heavily place-based context-specific nature of climate challenges make it just impossible to progress if the actors from all sectors, all types of actors, cannot identify how climate-relevant data can actually meet their needs. So climate services must be able to support action from the individual scale to the city, landscape, regional, national, continental scales. This requires a combination of simplicity, of accessibility, of clear relevance to the demand, and also of deep reliability. What it means for the way we design them and innovate is that we need to understand, and that's key, the gap that still exists between, on the one hand, the scientific and technological expertise that structures the supply side, so to speak, and on the other hand, the needs that could be supported by climate services, but that will only turn into demand if the potential users can understand how the supply side can address their needs. So being more innovative is not just bringing more technology. Of course, that is key, but it's also really looking at those more holistic, more integrated ways, more interconnected ways to address the issues. And this means also that single services are probably not going to do the trick. You will have to combine portfolios of services. And this needs to be understood by the supply side, but also by the demand side.
Okay, well, welcome back, everyone. I hope you enjoyed those testimonial videos from our colleagues across Climate Europe and across the community. We're now going to restart the session. I hope you managed to grab a drink as well, or a cup of tea or coffee. And it's my great pleasure to introduce Dr. Sam Granger. Sam is a research fellow at the University of Leeds, and he's going to talk to us a little bit about some preliminary research he's been doing, looking at user requirements, user needs of climate information in the Aspect project. And Sam's got an environmental social science background, particularly looking at climate services, uncertainty communication, the co-design of visualizations, and this in the context of water resources and also climate services in China and in other places as well. So over to you, Sam.
Thank you, Siraj. Just checking you can hear me and see my slides okay?
Yep, can see the slides and can hear you. Thanks.
Lovely. Okay, good morning. So yeah, as Siraj said, I'm a researcher based at the University of Leeds, and I'm working on the Aspect project within a team of mainly social scientists looking at the usability of climate information in Europe. So I'm going to very briefly run through what the current state of play is in terms of historical or current climate information use, and what we know about the potential needs and requirements of organizations and different sectors in Europe. Okay, so I'll start by putting the study into context and outlining our approach. I'll then summarize some initial findings from a review of peer-reviewed literature and secondary analyses. Okay, so as you've probably gathered, this work is part of the Aspect project. We've only just started, but hopefully in the next 4 years, we aim to better understand how climate information and knowledge can help organizations prepare and take action to reduce risk from a changing climate. We hope this component of the project will ensure that the scientific knowledge generated and forecast products and services being developed as part of the ASPECT project are relevant and usable for climate sensitive organizations in Europe. Okay, so to address the same, we are conducting, first of all, a rapid assessment of the current state of climate information use and user needs in Europe. And this will then inform later in the project a larger scale user survey, which will give us a more comprehensive and up-to-date picture of information use and user needs. Okay, so today I'll be discussing mainly our initial findings from this first activity, the rapid assessment of information use and user needs. Okay, so for this assessment, we've combined evidence from published literature, so both peer-reviewed scientific articles and grey literature from outside of academia. We're currently disseminating a short questionnaire to national Met services in Europe, and we're also in the process of analysing an internal user requirement database from the Copernicus Climate Change Service, which has been shared with us recently. And then lastly, we've recently put out a call for evidence on this topic, which I will discuss later in the talk. For this assessment, we're mostly interested in evidence of any climate information use, so we're not focusing on any specific prediction lead time at the moment. We're interested in how it's being used, so the types of use, in what context it's being used, why it's being used, the incentives for use, and perhaps why it's not being used. And also, lastly, the kind of any assessments, any analyses of user needs or requirements, both information needs and other more contextual needs. Okay, so in terms of our review of the peer-reviewed literature, we're using quite broad search terms, and by focusing only on European studies, we've identified just 8 articles that have conducted primary research into climate information use and user needs in Europe. So these studies can be broadly divided into 3 contexts of use. Firstly, seasonal climate forecast information for operational and risk management, and this seems to be occurring across multiple sectors, I think, as has been referenced earlier in the session. Secondly, more of a kind of adaptation planning context around sort of future longer-term climate change information, maybe around sort of storylines and that kind of thing. And then thirdly, really very tailored tools and products for citizens, or perhaps really local scale business sectors. So later on, I will discuss a little bit about surf tourism in Spain. So that would be an example of that. Okay, so the first project to really look at this topic in Europe was Euporius. So the European Provision of Regional Impact Assessment on Seasonal to Decadal Timescales. So this project, which was, I guess, it's over 5 years old now, could be seen as a precursor to the ASPECT project. So what the researchers did, actually Suraj was one of them, they drew from a workshop with climate service providers and interviews and surveys with information users, and they found that information use was occurring across a wide variety of sectors, and the extent of type of use really varied widely from sector to sector. As you might expect, there was a preference for timely and accurate weather information to inform kind of operational short-term day-to-day activities, and the kind of climate forecast, seasonal forecast and projections were more aligned with, again, as has been mentioned earlier, longer-term strategic organizational planning. So in many instances, there was a perception from providers that information was being underutilized, even when it's being used. These studies also found greatest demand for seasonal forecasts came from large private organizations, mainly in the energy, water, insurance, and transport sectors, as they seem to have greater resources and therefore be willing to experiment a bit more and take more risks and innovate in terms of information use. The second grouping of papers was really focused on the use of information for local climate adaptation. A paper by de Klerk et al. In 2021 investigated the provision of climate information in the form of stress tests, so looking at extreme precipitation, heat waves and droughts. And this was for the Dutch municipal adaptation policy. well, it's a kind of policy context. So like in Euporius, they also found information to be underutilized, and that rather than being directly applied to a decision, which required really information with high accuracy and resolution, these stress tests were predominantly being used conceptually for learning and strategically for persuading others within the municipalities. So interestingly, its influence depended mainly, rather than sort of on the accuracy of the information, mainly on how accessible the information was and the degree of interaction that took place between providers and users during policy formation. So that was seemed to be more of a priority in this context. So then focusing on climate risk assessments and management in the Finnish municipal context, Lassen and et al. From 2017 found that the needs of the municipalities were not uniform, and that there needs to be particular attention paid to building capacity and networking within these types of organizations and agencies, and there was a demand for help and guidance on how to apply the information within a kind of risk framework, climate risk framework. And then related to that, there's also included integrating kind of non-climatic information and factors that influence risks, for example, sort of spatial information and socioeconomic aspects of climate risk. Okay, so the last study I just wanted to briefly mention, I thought was quite interesting, focused on surf tourism as a potential climate service market and this was on the Iberian Peninsula in Spain. So the researchers used an online survey, and they found potential interest in more shorter terms, sort of timescales than what the Aspect project's looking at, so sub-seasonal to seasonal. And this was from individual surfers wanting to know if it's worth traveling to a particular location, maybe weeks in advance. And then in terms of information needs, these surfers really looking for a tailored interface, as you can see here in the bottom right, with a combination of atmospheric forecasts with sea state information and ocean cartography. There was also interest in seasonal forecasts from surfing companies, so from businesses locally planning expenditure a little bit further ahead in time, wanting to know numbers of surfers likely to be present and whether to offer sort of complementary activities if perhaps the wind and waves are low. So yeah, that I thought was quite an interesting study. But as I said, only eight papers that came up on our review. So in addition to this review, we're also conducting secondary analyses so that we can sort of triangulate evidence from multiple sources and provide a bit more robust findings. Again, as I said, it's important to include because there's such a sort of paucity of literature on this topic at the moment, until now I should say. And then sort of just coming towards the end now of my talk, we recently circulated a short questionnaire to national Met services in Europe, focusing on seasonal and interannual climate forecast, production, availability and use. Initial responses indicate that interannual information is not being provided widely, and while some agencies might be producing seasonal information, it is rarely being provided to the general public on a regular basis. There's also some indication that the greatest demand is from agricultural, energy and tourism sectors, which I guess would align with the literature. Yeah, there seems to be some concerns from providers that the users are a little bit unsure about the reliability of the forecasts, and there's perception again from the Met services that the users may not be sure how to interpret the forecasts and use the information within their context. So yeah, the survey is still ongoing, so hopefully we'll get more responses in the coming week. So very much preliminary at the moment. So yeah, as I say, this is sort of midway through the analysis. So preliminary sort of conclusion really to this assessment is that there's limited evidence of information use and understanding of user needs at the aspect timescale. So this, as you probably gathered from my review, it's mainly talking about sub-seasonal, seasonal timescales. So the Aspect project is looking at from a season up to 30 years ahead. So it seems like there hasn't been a huge amount of work looking at this timescale, and that's something we hope to do, with our larger scale survey later on in the project. Okay, so yeah, just to finish, I just wanted to draw your attention to a call that we put out for any information on this topic, really, in any language within a European context. So if you know of any studies that we'd really like to hear from you, just email me. My address is there, or upload the evidence by hitting the link provided here. But also, you'll find that link on our project website. So the deadline has now been extended to the 7th of April. So you've got a couple of weeks to send your information over. Okay. Thanks very much. That's it from me. Thanks, Suraj.
Great. Thank you very much, Sam, for giving us that overview, particularly of the peer review literature. And maybe you could put that slide on the call for evidence just back up again, Sam, because I mean, we do know that there is some use of for example, seasonal climate forecasts, but some of that hasn't come up to the peer review literature. So we would really love to hear if you've got examples of this being used, or there's a report, which may not be in English. You could go to the website, the link's in the chat now, and you can upload, any language documents that tell us a bit about this. So, because what Sam's provided now is what have we been able to find up to now in the peer review literature, and we clearly recognize a lot of this is happening outside the scientific papers nowadays. So yes, it's a real call out for evidence. So yes. Thanks, Sam. If there's any burning questions of clarification for Sam, please put them in the Q&A. I'll wait for a minute or two before we go to the next section. As Sam said, this is work in progress. We're gathering, as I say, the peer review literature, anything we can find that's not in the peer review literature, and then moving on to this call for evidence, and then the National Met Services as well. I have a question here from Paco, and I think it's for the wider project, really. I mean, I could try to have a go here. I don't know if you can see it, Sam, but I wonder if there is an explicit treatment of the interaction between climatic and non-climatic factors in aspects and the user engagement activities. I think that's a very interesting question, Paco. Thank you. I think up to now, and I mean, we heard from Javi earlier in the wine context. Clearly, organizations have to deal with multiple drivers all the time. Then some of them are climatic, and many of them are non-climatic. So at the moment, I mean, Aspect is broadly focused on the climatic factors in trying to predict the next season ahead and the next few years ahead. And I guess we'll probably utilizing the knowledge that our super users have on the non-climatic drivers to feed that into their decision making, and then figure out, well, what does then that mean in terms of, for example, adapting to climate change. Okay, I think in the interest of time, we wanted to run a couple more questions. So, Andrea, if you could put the Mentimeter back up. We just have a few questions that I think nicely follow from what you've heard from Javi and now from Sam as well. But we wanted to hear from you about, what are the kind of things that help you make use of climate information in your organization. And again, if you are maybe on the research side or on the translation side, you may have an inkling on this because of your interaction with users, but we also have some users and potential users in the audience. So we'd love to hear from all of you as before, in just a few characters, 3 words roughly. So sorry, you've got the Mentimeter code there at the top. So please, you need to go to the website. Sorry, the QR code is not there, but if you just Andrea's putting the QR code again, just in case. Great, thank you, Andrea. So if you could go back, it's the same one. If we could put that in the chat as well, that would be great. Okay, thank you, folks. Keep them coming. Okay, so we've got availability of the data, the fact that they're publicly available. Okay, visualizations. One of your fields, Sam, is coming up there. Okay, so I think, yeah, so the availability of tools, visualizations, metadata also quite important. Standards is also coming up, which is, of course, a key topic of Climate Europe 2. Dedicated funds. I think this is something we've heard before as well. Training, easy access of data, standardization. Yeah, sorry, standardization is meant quite a few times, sorry, in slightly different ways. So it's not being picked up because people have used slightly different way, American English, British English. So, but I think standardization would come up actually as a means, sorry, as a big one here. Okay, thank you, folks. We have a couple more we wanted to ask you. So maybe, Andrea, we move to the next question here. So now we've talked about the enablers, so the things that help you, use climate information. What do you think are the things that are preventing the use of climate information, either in your organization or because you've interacted with organizations that could potentially use climate information for the benefit of society? What do you think are the things that are preventing them from using it? So these are the barriers. Hopefully that's come up in your Mentimeter and you can now share some words with us. Okay, uncertainty, that was mentioned. Of course, we talked about uncertainty when in Jason's Q&A section. Complexity as well. Downscaling, of course, is an important issue and an aspect we'll hopefully deal a little bit with downscaling in its own work. Okay, I mean, this yeah, complexity has come up over and over by the looks of it. So there's clearly a job for us to try to improve the communication, I guess, for example, around some of these issues. Uncertainty, understanding. There are a few other words there around, you know, the spatial resolution as well. Kind of resources, you know, both human resources, I think, and financial resources in terms of being able to deal with things. Climate jargon. I'm going to introduce a climate jargon in the last question we've got for you, I'm afraid. So yes, I think let's just move to the final question. Thank you everyone for answering that. I think the final question was, we wanted to just get a bit of a sense from the participants here about what kind of climate information is of most interest to you. And sorry, the piece of jargon is prediction lead time here. So what you know, that simply means, you know, you're trying to predict a certain amount into the future, and so seasonal forecasts are trying to predict the next 3-6 months, maybe up to 9 months. And then you've got the sort of interannual decadal prediction, which is the new technology that Aspect is particularly focusing on, that goes into 1 year up to 10 years. And of course, you've got the sort of multi-decadal timescale as well, and you can pick, yeah, as many as you want. It's literally, again, to get a sense of, you know, what's most useful for your organization, or if you're advising organizations or interact with users. We would be very interested to see your responses here. Okay, I think in the interest of time, probably have to stop in the next. Yeah, I'm just waiting a bit to see if there's any more inputs here. So there's a bit of a cluster certainly around the seasonal timescales, and I feel like there's a cluster around sort of the long-term multi-decadal timescales. And perhaps this is not surprising, because the interannual timescale of sort of, you know, 1 year to sort of up to 10 years has not been, you know, is very, very new scientifically. And I think that's consistent with what Sam was talking about just a second ago, that there isn't a lot of use of interannual climate information, partly because it's maybe not publicly available in provided by National Met Services or Copernicus or others. So clearly there's a great role for the Aspect project to push that forward. So thank you very much, everyone, for engaging with this Mentimeter. I'm going to hand over now to Marta to take us to the next section.
Thanks, Suraj. And yeah, after this poll, which has been very, very interesting, because we have learned about the limiting factors of the use of climate information for your organizations, and also how much in advance would this or should these climate predictions be available so they can really benefit you. All this is very useful, and because it highlights your particular needs of climate-related information. And that's why this is a very good moment now to welcome our partner Dan Burney from the UK Met Office, who will bring us an interesting opportunity for users to engage with the project and address their needs of climate information. So Dan, can you explain us more about it?
Absolutely. So as we've heard through this morning, the role of users is absolutely central to the Aspect program. And particularly we've heard about the role of super users as organizations within the project who we work very closely with to develop new use cases for the seamless climate information that's being produced by the project. And some exciting news is that we're looking to recruit more super users into the Aspect program to work with through the life of the program. So it's always been part of the project design to start off with some initial super users. And we heard from Jason this morning that this includes some from the finance sector, from the governance sector and the missions for adaptation. And we also heard from Xavi earlier on his perspectives as a super user in the agriculture sector, and specifically in wine production. But we're now looking to hold an open competition for new super users to join the project. So what's in it for you for doing this? So first of all, it's an opportunity to develop your understanding of climate and weather risks that affect you, working closely with leading climate scientists, both at the Met Office and at Barcelona Supercomputing Center. And it's an opportunity really to work with Aspect to develop these very tailored, specific and detailed use cases that are really aimed at your organization and the decisions which you need to make over timescales from months out to the next 30 years. And ultimately from this to really help you make better decisions around weather and climate risks. Now, from Aspect's perspective, the way we're benefiting from this is that we get insight into the understanding of those detailed decision contexts from all of the super users. And then we get to see how these kind of insights might be transferable and apply to other sectors and to other decision makers, and to really scale out the impact of the use cases which are developed. And so what we're looking for really, and in terms of expectations from super users, is really about the commitment to work with the project in a very open dialogue with the researchers, so that we can really get into an understanding about the factors which influence the decisions that you need to make. Now, an important part of this is really not just committing time and being an active part of the user forum and working in co-developing those use cases, but it's really about the willingness to share the information you have about your understanding around weather and climate risks that you face. So this is about the exposure that you have to potential climate hazards, you know, if this is assets or staff or locations of buildings. And it's about your understanding of how those are vulnerable to different hazards. And by combining these exposures and your understanding of vulnerabilities, we can work with you to combine that with the climate predictions from Aspect to really better estimate the risks that you will face, and to really help better inform in a very targeted way the risk management and climate decision making that you have to make. So who are we looking for in this? So it is an open competition. I guess the main criteria from this are really that we're looking for organizations who are working in socially, societally important sectors. Okay, so we've already mentioned that we're working with aspects of agriculture and finance and governance, but we have a very open mind as to what other sectors that we would look to work for the other remaining super user slots, be that water resources, be it energy sector, be it transport, or even health as well. And so we would love to hear from any particular users that can understand the benefits of how climate information and adaptation can make a very tangible impact to them and the wider sector. And as I say, we're looking for organizations working in societally important sectors, but that is fairly loosely defined. So we'll be launching this competition soon at the next user forum, which is in the second half of April, the 21st, I think. So please register your interest for that through the Aspect mailing lists. And yeah, we'd love to hear from you if you're interested in joining the project. Thanks very much.
Also, if you have any question regarding what Dan has just explained, please ask them in the chat. So, well, in the question and answer, and we can provide some clarifications. In the meantime, I would like to ask you one thing, Dan, and it's about if there is any, let's say, criteria for becoming a super user in terms of the use of climate information. Should these people be familiar with data, with climate data?
So we don't necessarily have to be an expert user of climate information. So we are looking to broaden the engagement with climate research beyond those who have been regularly involved with research programs on climate prediction in the past. So not necessarily to be expert, but at least to have an awareness of the vulnerabilities that they have and the exposures that they have, and an appreciation of how incorporating knowledge about future climate conditions might actually benefit their operations. And that doesn't have to be on any particular timescale. So we're particularly interested in people that have decisions to make over a number of different timescales. So historically, I guess, then if information from seasonal timescales, and then on interannual timescales, and then out to sort of climate prediction timescales, would need very different systems historically in order to inform about those future conditions, which would mean making potentially different decisions that have impacts on different timescales, using information which is by definition not seamless, but sometimes hard to reconcile. And so one of the real kind of benefits that Aspect will bring from developing this seamless information is a kind of a single point of contact, as it were, for getting that climate information, and without having to make those what can be really quite expert judgments over which particular systems would be appropriate for which types of decisions and questions.
Okay, thanks, Dan. We have a couple of questions in the questions and answers box. So one is, how are you measuring or defining this socially driven organization label?
So that will be as part of the competition. That is part of the case to be made by people that are interested to do it. I'm not going to rule out any, but I dare say if your business is online gambling, it's not for you. But so aspects which might affect the well-being of people in different ways, so be that kind of transport networks, sort of the resilience of energy infrastructure, or direct or indirect effects on people's health or animal health, come to that as well. So we have a fairly open decision, as long as if you can't see that the organization you're working for has some kind of societal importance, then that might rule you out. But it's a very open competition from that, and we will take an objective view. And so one of the things that we're also looking to do is that we will be looking to balance the kind of geographical spread as well of the case studies that we're developing for different users, super users as well, to make sure that there is a spread across Europe.
Okay, another question we have is that how important it is that it's an international organization.
So it doesn't necessarily have to be an international organization. I think if you have a broader set of distributed interests, then that's going to make it a more tractable case for getting useful and actionable information from the prediction system. Whereas if you're based just on one particular point, that's going to be challenging. Whereas if you're a national organization, that's a larger geographical cover, and that's going to help getting skill on longer timescales. And being an international organization obviously covers that broader geographical spread. And I guess there's also the other side of that is then if the broader that your reach is, then potentially the benefits that will be seen from actually utilizing the new seamless climate information system in your decision making could actually have a bigger impact as well.
Okay, thanks. Actually, the same person that was asking about the international reach was also proposing one organization about Gesundheit, so health, that we can have a look in the chat as well, and then perhaps answer in the chat directly. And then there is one more question that I can see now, which is about, you mentioned that we expect some contribution from the super users, so to be involved in some stages of the project, and they are asking about how much time do we expect for that, if there is any estimation, and if there would be some compensation for the time of these people.
Yeah. So I don't think there is funding associated with that. So it is difficult development of the proposal to kind of know how much would be held back for that. But the level of time commitment that we would expect would depend very much on a case-by-case basis, but we would expect so ongoing communications to attendance with meetings at different points throughout the development of those use cases. So I think it's fair to say that earlier on in that process, so to help scientists within Aspect kind of understand the decision-making context under which you're needing to use weather and climate information, there might be slightly more intensive, and then that might ease off a bit, but it's difficult to put a figure on it. But we wouldn't be expecting full-time members of staff to kind of match the level of input from Aspect on this.
Okay, thank you, Dan, for all these clarifications. I don't think we have any more questions now on the chat, so I would advise Dan to continue with the next slot that we have planned for this. Suraj, over to you.
Great, thank you very much, Dan, for explaining what this great opportunity, and of course we'll get out more details at the second part of the user forum, particularly in terms of how you can apply. This was literally a bit of a heads up to the community that we have a couple of spaces for you to join us in this journey, in this particular project. So next, we would like to invite two colleagues who've got a lot of experience in the development of climate services, particularly in that aspect of translating some of this complex climate information into products that are usable by decision makers. So we wanted to hear a little bit from them. And so we're very lucky to have Professor Alberto Troccoli. He's the co-founder and managing director of the World Energy Meteorology Council, and also a visiting professor at the University of Leeds. And he's got over 25 years experience in working at this interface between meteorology and climate. And I'm going to hand over to him to give us some views and reflections of the development of climate services. Before another colleague comes in, and please, continue putting questions in the Q&A because there'll be time to ask a few questions to both our speakers. So Alberto, I'll hand over to you.
Hello, thank you very much, Suraj, for the introduction, and actually also thank for the hidden offer to have a position at Leeds. I've never been to Leeds, actually. Sorry,
Sorry, University of East Anglia.
Yes. Yeah, but I will wait for the offer of a contract. Yeah, thanks. Jokes aside, thanks very much, Suraj, and also Yara for the kind invitation. It's a pleasure to be here. I only have a few minutes, and I was also asked to provide some provocative thoughts, I think. That's what you expect, Suraj? Yeah? Okay, good. So let's go. First provocative thoughts about water boiling. So what is the water boiling? I didn't put any label because I want to leave a bit of suspense, and I'll remove it straight away. So the fire under the water is the funding from the EU and other organizations, institutions. The water, and especially the bubbles in the water, all the activities in climate services in this case. I mean, this can be generalized to any sector really, but let's think about climate services. So what happens with all the funding? There's a lot of bubbling of activities, especially in terms of case studies. I do believe that the case studies are the main vehicle. Obviously, there needs to be underlying science, but the case studies are the main vehicle for interacting with users. And that's what we've been doing over the last 10 or plus years. And so there's been a lot of activities, a lot of chaotic activities, but I think it's good. I mean, that's how any business starts. There is funding, there is support from governments, and there is activity, and then you don't control it. You just let it go. You let it boil. And some of the bubbles, I know, I hope there's no physicists in the audience because I'm going to say something silly, but some of the bubbles then go in the air and they become these nice balloons. I don't think there was any soap in the boiling water, but never mind. That's part of the story. So this, some of those bubbles then make it into the real world and become these colored bubbles. And these are I would say, the companies that make it to pass the first obstacles. There are many obstacles to start a company, and this is true of any startup. And so some of them will make it. It's like I said, it's true for any automobile, any sector, solar power. You need that initial incentive from government, but then you have to let it go. I don't think it's any good to put regulations in the way we do climate services. I mean, to me, climate service is really just a question of translating climate information into something that is useful. I don't see really the need to regulate the way in which we do it. What I see, though, is that in order to achieve this, you need, many things, but let's say a recipe of 3 things. One thing is good expertise, that's useful. And second thing, it's a good plan, also useful, particularly a data management plan. And the third thing is good ethics. So, and this is the only thing I believe that is very difficult to control. And that's where I think the community is well placed to provide guidance on what should be the role of climate services, and particularly, put some boundaries, which could be done through certification, let's say. So this was just a little bit of introduction and hidden kind of or work on not work, but a hidden kind of a storyline behind what we've done over the years, at least personally as well, in climate services. We achieved this state of creating something that is now useful for users. So what is useful in our case, we found is tools that can display what we are doing. I know sometimes tools like visual tools are overvalued, and I know I'm also aware there is a very large graveyard with all these tools, and we don't want to add any more than necessary. But I think it's also necessary. I found that it's really, really important to have this tool. And if it works well, it's also a good way to sustain the service, because having little pieces here and there and collecting a plot here and a document there don't last very long. I mean, it lasts in the area of consultancies, but not in services that can have a long life. And so, just going a little deeper on this, we've developed this over the years, and we now have a public version that anybody can access here. You see the link on the previous one, but we do also have a number of versions with modules that are tailor-made. And here I'm showing specifically one on seasonal forecast, just to be a bit more concrete and not talk about the sex of the angels, as we say in Italy. So that's what we do. We have this tool that is used by users and then provide information about the spread of seasonal forecast for 2 systems 6 months ahead. It's updated operationally. So every month you get this information. And underneath here is the anomaly, just the difference from the mean and from the climatology, because that's what users want. They don't want very complex information to start with, at least. And to finish, I just want to thank the many funding agencies and projects that have supported this work over many years. And I also want to leave you with a thought for now, that time for decisive action on climate is yesterday. Thank you. Over to you back, Suraji.
Thank you very much for that provocation, Alberto, and apologies for getting the university incorrect earlier. I'll hand over next to Paolo Mazzoli. Paolo is an environmental engineer and technical director of Geosistema in Italy, and he's also got a lot of experience in environmental impact assessments, hydrology, and hydropower design, and was involved in the Clara project developing climate services. So Paolo, I'll hand over to you for a brief explanation of what type of climate services you folks have been doing.
Thanks, Suraji. And you see my screen? Yeah.
Yes, I can see it. Yeah.
Thanks again, and thanks for inviting us to this very interesting opportunity and thoughts about climate service work, which we are working on. I'm Paolo Mazzoli, the technical director of Geosistema. We are a small environmental engineering company based in Italy 20 years ago, and we provide consultancy indeed to private, to public clients in the fields of water, energy, air pollution, and climate adaptation as well. Working with many tools like environmental models, GIS, geospatial data and analysis, particularly the massive amount of data coming from the Copernicus world, predictive analytic, data science, machine learning. We keep one foot on consultancy, we provide services, and the other foot on research and development, participating to co-funded Horizon project. Most ended recently, like Clara, and some ongoing, which I'm showing you in a while. But today, let's talk a little bit about the climate service we are going to develop through this R&D activity, because there's been a lot of talk about such kind of application, and I do agree with most of the conclusions and outcomes of the previous part of the workshop. They really fit our experience. For example, in Clara, this H2020 project ended recently. We have developed a climate service, adding value to the seasonal forecast coming from the Copernicus world. We put the seasonal forecast coming from a Copernicus data store that was moving his early step at that stage, together with the local knowledge of Enel Green Power, which is a major player in clean energy production around the world, in order to get a service that can forecast the energy and discharge to 2 hydropower plants in Colombia. How? We just put the upstream forecast, coupled them with the local recorded data of Enel, and processed everything in the cloud through machine learning algorithms in order to get the forecast and provide this information through just a web service. A web page, the access could be done through a simple web browser. Because I do agree also with one of the points that have been raised recently also by Alberto. Those services should be simple, easy to use. In Clara, we developed something similar, but for a very different target, agriculture. We were working with a land reclamation consortium and developed a service that take the decadal prediction, again from Copernicus, coupled that with a soil crop balance model, and provided information at a parcel level inside the territory of the land reclamation consortia on expected irrigation demand. And now this could change in the years to come in order to plan, for example, changes in the distribution irrigation network investments to cope with the expected change. But these are just 2 examples. We are working in this way also now. For example, now we are involved in an ICISC, which is a Horizon project all about focusing and developing climate services human-centric. What does it mean? We are, for example, working in Italy with a set of users to develop a forecasting service for freshwater availability in a river for the next days and weeks. So different lead time, but similar concept. Again, we're searching for upstream information coming from the Copernicus world, particularly forecasts of discharge of the next days and weeks, coupling with the information of the network that the regional environmental agency has, and try to get a new service that gives information tailored to the local needs on the incoming discharge for different users. And we are working in laboratories in this case. So all these people, land reclamation consortia, hydropower producers, regional environmental agency, the regional government, that brings inside this process, this co-development process, needs, ideas, and expectations, and also their knowledge and intelligence to develop a tailored climate service. A very different application, but a quite similar concept. You understand, I mean, that there's a fil rouge in this approach we are following for climate service development. Here, for example, we are ongoing with this directed project, which is on climate disaster risk management, so another topic. We are working with civil authorities and first responders to develop tools, knowledge, new ways to deal with disaster risk reduction and climate change adaptation, but again, in laboratories. So I would say that the fil rouge in developing all the climate services in the recent past, at least, and now ongoing, is to keep the user interaction through laboratories to direct interaction, not at one side, but at the very heart, at the very center of the developing of this climate service, regardless the specific application we are using, and to try to put in value the upstream information from climate service like Copernicus or providers of climate knowledge and intelligence at a higher scale down to the local level. That's the way we are in these years, and now try to work and develop and create also added value through our services. That was my general overview of how we deal with the climate service world.
Great, thank you very much, Paolo. And also Alberto, I think both your talks are fascinating and very complementary, actually. Alberto, you had some examples, sorry, particularly for Aspect, it's interesting because you had some examples from the seasonal timescale, Alberto, and Paolo, you had some examples from the sort of interannual. So I'm going to kickstart with a question, which I'd like to pose to both of you, really. I guess maybe sticking to those timescales, could you just say a little bit more about who is using, I guess, some of these products that you were showing us, right? And in what way are they potentially being used? Are they actually, are users kind of, you know, incorporated into their operational strategic decision-making, or are they just having a look and saying, interesting, but we'll put it on the shelf? Just give us a peek a little bit, because you're really, you guys are at the interface. You're really dealing with, I think, you know, regions across Europe. You mentioned, you know, water companies and so on. So I'm just curious to sort of hear from you, especially given what Sam said earlier, right? That in the literature, in the peer review literature, there isn't a lot of examples yet of use, but clearly a lot has developed since the Euporius project, which was, you know, finished in 2017, and there's so much more availability. There's Copernicus. You both, I think, mentioned it heavily. So just wondering, could you each one comment? Maybe starting with you, Alberto, when maybe at the seasonal timescale, you showed us an example there. I mean, who's using some of this information and how?
Yeah, no, thank you, Suraj. Well, first of all, sorry, can I just correct the record? Because although I've been speaking English for a number of years, I made a bad mistake before. It's not the sex of the angels, it's the gender of the angels. So, sorry, it was pretty bad. Anyway, without naming names, I can tell you that there is a broad range, and and there's a reason also I don't want to go into too much detail, because I think, you know, there are people who, let's say, traders, they just want to look at, they need to have quick decisions. They need to know, you know, within a space of a few hours, what's going to happen. This is mainly for the short time, but also seasonal. You know, it's very important, the timeliness of the seasonal forecast. That's why people pay to get the forecast. They don't wait for the C3S to get out on the 13th of the month. But as many people know, if you don't know now, the ECMWF is available on the 6th of the month now from C3S. So also information for the competition. So that's very good news. So the timeliness is very important, and that's why, you know, it's true. I learned many years, and I didn't think it was true, but I think it is the case that it's like in the share market. Who goes first gets the priority in the lineup of the decisions. And so this is one end of the spectrum. They look at the math, look at the conditions. On the other, then there are people who actually take the data, but then they feed it into their decision-making models. And because they're so complex, let's say big energy companies, let's say the models are so complex, econometric models that work out power production for solar, wind, and demand, and all these things, an external person wouldn't be able to operate that. But then there are also other users who are not small, but they're not so expert, and they ask for setting up the whole system. And so we have experience also. We have one customer who's asking us to set up the system, particularly now for the drought that is, again, unfortunately happening in Southern Europe. In Italy, we're going to have probably an even worse disaster than last year. And so people are getting very concerned about that. And in that case, we are able to provide the whole value chain from the forecast down to what is the meaning for you in terms of water resources, for example.
Great, thank you so much for sharing that wisdom there, Alberto. By the way, if you folks have got any questions for Alberto or Paolo, please put them in the Q&A. But Paolo, do you want to also answer that question? And yeah, it could be seasonal, interannual, as you wish. Yeah.
Yes, I feel quite in line with Alberto's conclusion. I mean, there's many different ways the user can interact with the service and needs they express through the service. But typically, there's people like the hydropower producers, so to speak, that needs to plan, for example, maintenance in the next 2 or 3 weeks, that needs the information timely and operational. I would say the operational availability of the information can make all the difference to them. No, that's one kind of user. While on the other side of the story, there are users like the planners, municipalities, water managers, regional authorities that have typically a longer perspective. They can use both the information on the next incoming season to plan, anticipate the needs of the emergency draftman agent, so to speak, speaking about water availability, and look in a climate perspective to set new rules for the years to come. So there's the time, I would say there's this time divide between the two kinds of users. Another way I would like to divide, if I may, the users that work with our services is the level of expertise and needs to tackle and somehow customize the service. Some are more interested in getting the information, as I say, timely and with sufficient accuracy, and they don't want to bother about setting up the entire system, knowing exactly which kind of model you are dealing, as long as numbers are reasonably well. Some other ones need to be more guided through the entire setup of the climate service that shall be, for example, customized to their need. I'm thinking about the technical services of the regional technical services that has an in-depth knowledge sometimes of the process. And for example, shall we set up a coastal flood system service, which is a field we work on, we shall definitely deal with them and also go down and deep and customize the service. But I would say that the fil rouge across all is that we have to link, we have to tackle the climate service to the decision process. That's where the final value of the service is, and we have to keep this in mind from the very beginning to the end of the climate service development process, having in mind which kind of decision they can take already. This is a topic that's been clearly put in the light during the webinar, and I totally agree with it.
Great, thanks both. I'm going to squeeze in one more question because we've got one from Ashwini here, which I think is very interesting, connects to the topic of uncertainty we talked about earlier. And I think it's something you folks have to deal with. So it'd be great to hear your experience in this. But how do you address the uncertainty in the services delivering seasonal annual projections that are required for decision making? Uncertainty in the climate data. Yeah. Do you want to go first, Alberto?
Yeah, certainly. So yeah, thanks. I would say that uncertainty is very important to communicate, and also it's a very big obstacle in the uptake of seasonal forecast. And I didn't mention it, but it's a similar kind of process also in the projections. Yeah, when you go to other, the underlying issue with all this climate information, climate data is the uncertainty, and that's why it's taken longer than weather forecasts to be used. So and that's why we're spending much more time. I mean, the weather forecast services went through much more smoothly than climate services, and like I said, the reason is this uncertainty. However, it's interesting also to know to see that when you actually get people to use the information, they don't want a lot of information about uncertainty. They want to know that the information is coming from a reputable source, that you are, credible and everything. And like I showed in the kind of visual that we have our tool, it's very simple. We were asked to keep things simple, and that's why it works. If you make things complicated, if you start to add, the skill over the last 20 years was such and such, and blah blah blah, you kill the audience, our users, our customers. So basically, the message is yes, convey the uncertainty. Make sure that you don't give the information as if it was black and white, but in the end, people want to have a very simple message and storyline. And in the end, so just to conclude also, from my perspective, the important thing is that the climate information is used. I'll make sure that I present things in a very rigorous way and everything, but my main goal is to make sure that this information is used in the end. And so it's important to keep communicating this, the usefulness of this data, despite the uncertainty and the limitations.
Paolo?
Exactly. But basically, Alberto already covered the answer, but just to add one consideration to what you say, yes, there's we work a lot on assessing and stating the uncertainty of the information we take, and for example, the performance, the skills of the forecast we provide, so to speak. For example, if we do forecast discharge in a river, then there are many ways, graphs, tables, and root mean square error, and all the metrics to state. But what's more important that the user shall understand which is the impact of this uncertainty on the final decision. For example, you can be very excited about making a forecast system that performs well, reasonably well than a benchmark than what they have in-house. For example, 20% more accuracy or reduction in the error of the forecast, but then you shall tackle this to how much does it impact to the final decision. For example, which is the increase or decrease in revenue that comes with this increase in performance. So I would just add the consideration that we have to link the uncertainty to the effect that this has to the decision process of the user again. I'm stressing a bit on this. That's it.
Great. Many thanks, Paolo and Alberto. I think that this has been very, very insightful to hear from your experiences, and certainly something that, we in Aspect will take on board, and hopefully the wider community as well. So I guess what, final words for me are really to thank everyone, all the participants of this first user forum, all the panelists. Thank you for your talks. As I said earlier, I want to repeat just a couple of things that were mentioned a little earlier. So we want to continue this user forum in the 21st of April. Hopefully a colleague of mine will put the registration link in the chat. So we really hope you've got a bit of an overview of what the Aspect project is trying to do over the next 4 years. And you've got a sense of some of the research we're about to embark on, and also you've heard about some of the user needs and the climate service experience that we've accumulated over the last decade. So we'll be building on all that, but we'll be picking up, I think, where we leave sort of today, particularly to go into a bit more detail of some of the technology, some of the issues we've talked about just now, around uncertainty, also issues around skill, especially in terms of some of the new features, for example, around interannual and decadal prediction. So please, I'd encourage you to register. The link is in the chat. You can use the QR code as well to register, and we look forward to seeing you there. But before I go, just a very quick recap of a couple of opportunities. If you are a potential user of climate information, Dan Burney from the Met Office earlier gave you a heads up. We would love to hear from you. We'll officially launch this next month, this competition to join, Codernu, Clear Gas, and some of the local governments that are working on the admission. These are already some of our super users, but we're very keen to have a couple more where we can try to develop climate services for you, as Dan described earlier. And then again, we were sort of saying, it was fascinating to hear from Alberto and Paolo. There's clearly a lot of experience on both using climate information across Europe, across timescales, across many different sectors. So if you are able, if there is some reports in any language, really, we'd love to hear about that. I think Alberto nicely demonstrated that, some stuff is in the private sector domain and it's confidential, and people need to use this very quickly, and perhaps we won't have access to that. But if some of this material is in the public domain and we're able to capture it, we really would love to hear from you, because in Aspect there is a possibility of informing some of the science still, and clearly there is tailoring that can be done across those timescales of prediction lead times of 3 to 6 months, all the way up to 10 years. So this is why this work is so important in terms of trying to understand not just the decision-making context of many potential users, but also how, what experience have existed in the past. And so it's been really useful to hear that from our colleagues. So I think with that, I will finish off. Again, please register for the second part of the user forum. We'd love to see you there in about a month's time. Thank you for joining this first user forum. Thank you, Marta, for co-moderating with me, and all the other colleagues in the back room who've helped make this happen. So I'm going to stop talking and say that the next session in Climate Europe 2 starts at 2 p.m. Central European time, and you'll hear about another sort of sister project. I think the Climax project will be talking about what they're up to. So hopefully see you there. But thanks everyone. Have a good lunch break, and look forward to seeing you in April. Okay, bye.
Bye.